let's apply exponential growth and decay. One place where we apply exponential growth is in compound interest. And the formula for that is this. You've all seen it before. Basically, if you go to the bank and invest some money in the bank, this tells you how much money you will have at the end of a term, right? So P is the principal, not like Miss Howard, but how much money you go to the bank with, right? R is the rate in decimal. T is time in years. Okay. And N is the number of times per year that bank pays you interest. Okay? Now, if interest is paid to you continuously, then this is the formula. A equals P e to the RT.
Which one? N is there? Is in it twice?
And so okay, so it depends. So if the account that you purchase, right, that you sign up for, pays you quarterly, that's 4 times a year. If the account pays you semi-annually, that's twice a year. Right? Okay, so take a look at this formula. Do you see how you have 1 plus 1 over n to the n? Do you see that?
That's
Does
like,
that?
Yeah.
That's like 1 plus 1 over x to the x. That's like e, isn't it?
It is.
Right? So now, that's like that one. So, if instead of the bank paying you 4 times a year, suppose they're paying you every nanosecond of every day, then they're paying you an infinite number of times. So n is infinity. And if that thing goes to infinity, that's e. That's where it comes from. Okay? So A equals P e to the RT. You use it only if you see the word continuously. Okay, so let's... Compounded means paid. Like interest is paid continuously. Okay. Mrs. Drew invested $2,000 into an educational account for her daughter when she was an infant, when the daughter was an infant. The account has a 5% interest rate. Okay. If they don't make any other deposits or withdrawals, what will the account balance be after 18 years if interest is compounded quarterly? So if interest is compounded quarterly, then n is 4 times a year. Okay, so R is 0.05, T is 18, $2,000 is the principal. So A is P, 1 plus R over N to the power of NT.
Wait, how do you know when to use which one?
Because this does not say continuously, this is the one you use. It says n is compounded quarterly, that means n is 4.
What's the difference?
You'll see right now.
Continuously is like
You'll see right now. Yeah, let's do this one and I'll tell you guys. So 1 plus 0.05 over 4 to the power of 4 times 18. Okay? So at the end of, okay, so here we go. It's 2,000 times 1 plus 0.05 divided by 4 to the power of 4 times 18. So after 18 years, she will have this much money. Okay, you have to round it to the correct amount of places, okay? All right, sorry. No, okay. So, okay, they were, but they left. Okay, so now, so she finds an account that will pay 5% compounded continuously, right? So another bank they kind of poach her and they're like, hey, come to us. We're not going to pay you just 4 times a year like the other bank. We're going to pay you continuously. Paid you again, paid you again, paid you again, right? So she's like, oh my God, that sounds like a better deal. Okay, so now how much money will she have? Okay, so now the question is, when will her investment triple? Okay, so now we're going to be using this formula. Now, P was 2,000. A is 6,000. That's the final amount. You want it to triple. R is 0.05, and we're looking for T. So 6,000 is 2,000 e to the 0.05 T. Okay? This is the only time where I'm going to use prior knowledge. I'm going to have you guys apply prior knowledge. So divide, you get 3 equals e to the 0.05 T. Do you remember how back in the day, in like last year, when you had this, you took the ln of both sides? Do you remember? So ln of 3 is 0.05 T. Divide by 0.05. T is ln of 3 over 0.05. ln and e cancel each other out.
So the
Why is
exponent
that?
becomes like a non-exponent anymore?
I guess.
Yeah. So this is what you did last year. So basically when you have 3 equals e to the power of something, you take ln of both sides. ln and e go away and you just have the 0.05 T left.
Okay.
Yeah.
How come ln cancels e? Why?
They're inverses of each other. We're going to go into it 2 more sections from now. So ln of 3 over 0.05, 21.97 years. Yeah. Okay. So basically in 2022. Oh, this year.
Wow.
Yay. Okay. All right. Let me do this quickly as well. So in addition to investments, other fields can also change at an exponential rate. They include populations of people, animals, bacteria, amounts of radioactive material, okay? So here is where, okay, so your book chooses to use n as their variable, but everywhere else is u, it's y, so I've given you both. So the initial quality, we call it n naught. N sub 0 is read as n naught, that's the initial quantity. The rate is r or k as a decimal, and n is the amount afterwards. So if you have exponential growth or decay, the formula is n equals n naught or y equals y naught 1 plus r to the t. This is my preferred one. Okay? Y equals y naught. And then if it's continuous, it's y equals y naught e to the kt. Okay, so listen. Usually we use r when it's not continuous for the rate. When it is continuous, we use k. And we're going to use the formulas as they are. Just know that if something is a growth, then r and k will end up being positive. And then if it's decay, they'll end up being negative. But you're not going to artificially do that. It'll just come out in the math. Okay? So, take a look at this one. A state's population is declining at a rate of 2.6% annually. The state currently has a population of approximately 11 million people. So y naught is 11 million. If the population continues to decline at this rate, predict the population in 15 years. So you want y in 15 years. Did it say it's continuously declining? No. So we're going to use the first formula. And the rate is 0.026. But it's declining, right? So it's negative. So y equals y naught 1 plus r to the t. Y equals 11. Don't deal with all those zeros for the million. 1 minus 0.026 to the power of 15. Okay?
Wait, where the in the formula isn't it KT?
So that's for the continuous one.
Oh, okay.
So you can plug that in, right? And it'll be like, I think 7.4 or something, right?
Are there other words that will tell you that it's like a continuous?
It'll have to say continuous, yeah. Okay. So let me do this one as well. Did you plug it in?
Yeah, but should it be like 1 minus negative?
No, it's just 1 minus.
Okay. I got 0.1019.
Are you sure?
I probably did it.
Let me see. 11 times.
No, it said 0.26 instead of 0.06.
Oh, yes.
So now it's 7.409.
That's what I thought. Yeah, I remember that being 7.4. Why can't this thing go away? All right, so 7.4.